In this problem, we are given a steel bar that is 50 millimeters in diameter and it is 2 meters long, surrounded by a shell of cast iron that is 5 millimeters thick. We are tasked to compute the load that will compress the bar a total of 1 millimeters in a length of 2 meters, given the modulus of elasticity for steel that is 200 gigapascals and the modulus of elasticity for cast iron equal to 100 gigapascals. Now, because the cast iron is binded on steel due to the force P applied on the composite figure, it will tend to produce a deformation of steel that is equal to the deformation of iron. And to solve for the total force P, we utilize the formula for the deformation of steel and iron and solve for the applied loads on each material. And to solve for the total force P, we add up the applied force due to steel and iron. So solving, we have the deformation of steel that is equal to the force applied on steel times its length divided by the area of the cross-sectional for the steel times its modulus of elasticity. And for the cast iron, it has an applied load, let's call this P sub IR, times its length divided by the area of its cross-section times the modulus of elasticity. So you have the deformation for steel equal to 1 millimeters, equal to the applied load times its length of 2000 millimeters equal to 2 meters divided by the area of the cross-sectional for steel, that is pi times diameter of 50 millimeters squared divided by 4 times its modulus of elasticity equal to 200 gigapascals or 200,000 Newton per millimeters. Now we can solve for the force applied on steel, that is equal to 1 millimeter equals force applied multiplied by 2000 all over pi 50 squared divided by 4 times 200,000. We get our final answer equal to 196,349.54 newtons. And to get the force applied on the cast iron, we have delta IR equal to 1 millimeter equals the unknown force times its length of 2000 millimeters divided by the cross-sectional area for the cast iron, that is, we multiply pi by the outside diameter equal to 60 millimeters squared minus the inner diameter of 50 millimeters squared all over 4, and multiply this by the modulus of elasticity. Let's move this here. That is 100,000 megapascals or Newton per millimeter squared. Now we can solve for the force applied on the cast iron. So we have 60 squared minus 50 squared, and this is 100,000. Shift solving, we get 43,196.90 newtons, and that is the force applied on the cast iron. Now that we have the forces applied on each composite, on each material, we will now solve for the total force applied on the composite figure. So to get P, we sum up the force applied on steel and the force applied on iron. Doing so, we will get our final answer, that is equal to 126,349.54 plus 43,196.90. That is equal to 239,546.44 newtons. Or we can convert this into kilonewton by multiplying a conversion factor of 1 kilonewton per 1000 newtons. Newtons will cancel, we get P equal to 239.644 kilonewtons, roughly equal to 240 kilonewtons. And that is our final answer.